So this entire unit we've had expressions because we didn't have an equal sign, and today we're going to solve equations that have fractions. So since there's an equal sign, our approach is just going to be a little different. Before, we would have to multiply the numerator and the denominator because we were working with expressions. So we didn't have the ability to do whatever we want. And now that we're throwing in an equal sign in there, we can do whatever we want as long as we're doing it to every single term. So an example would be y over y minus 1 equals 8 over y plus 1 over y minus 1. Now when you were adding and subtracting fractions, you had to find a common denominator. In this case, you're not trying to find a common denominator, you're trying to eliminate denominators. This equal sign changes our approach. So now we can do whatever we want as long as we're doing it to every single term. We have 3 terms, so whatever we multiply by, we have to do it to all 3 things. So then what you have to do is see, what do I have in my denominator? I have a y minus 1 and a y. So that's exactly what I'm going to multiply by, but I'm only going to multiply the numerators. So first, I'm going to multiply all 3 terms by y. Now let's rewrite what we have. We'd have y squared over y minus 1 equals, well, the y's cancel here, 8, and I'll even say over 1, plus no y's cancel here. I can't cancel these y's because of that minus sign there. Y over y, not plus 1, minus 1. Minus 1. So now I still have one denominator remaining. Well, there are 2 of them, but it's the same thing. So I'm going to multiply all 3 terms by y minus 1. Okay? So let's rewrite what we have. The y minus 1's cancel here, leaving us with only y squared equals 8 times y minus 1, and the y minus 1's cancel here, plus y. Now we've eliminated all of the denominators. This is a little easier to solve. This is a second degree equation, so let's get it into standard form. Let's first distribute this 8. Let's combine like terms. And let's move everything to the same side of y squared. So let's subtract 9y and add 8. And this is factorable. The factors of positive 8 that add to negative 9 are negative 8 and negative 1. Okay, so we get y equals 8 and y equals 1. However, we're not done yet because we get to go back to our original equation, which had y minus 1 in the denominator, y in the denominator, and y minus 1 in the denominator. If we take a look at our original equation, which values would have yielded a 0 in the denominator? Well, y can't be 0, then we'd have 0 in the denominator. And y can't be 1. 1 minus 1, 0. Can't have 0 in the denominator. So we will reject this solution. Because if we plug y equals 1 into the original equation, we would get 0 in the denominator. Okay? Next example. We have x over x minus 4 minus 1 over x plus 3 equals 28 over x squared minus x minus 12. In the last example, we didn't have to factor anything, but in this case, we're going to factor this first to see what terms do I have in the denominator. So let's just rewrite the first terms because they're not going to change. Equals 28 over x minus 4 and x plus 3. So if you notice, what do we have in the denominator? We have an x minus 4 twice, and we have an x plus 3 twice. So that's what we're going to multiply by. We're going to multiply by x minus 4 and x plus 3. You could do it at the same time, or you can do it individually. I would do it individually. Let's first multiply by x minus 4. And again, we're trying to eliminate the denominators, so multiply only the numerators. Okay, so wherever it appears in the numerator and denominator, I'm going to cancel it. I'm not canceling there, and I'm canceling there. So let's write what we have left. X minus all of x minus 4, and that's still over x plus 3, equals 28 over x plus 3. So we still have a denominator of x plus 3, so we have to multiply all three terms by that. If you start with 3 terms, you're going to have 3 multiplications each time, even if there's a 1 remaining there. So let's multiply all 3 terms by x plus 3. And wherever it appears in the numerator and the denominator, I'm going to cancel it. So it's right where we have left. X times x plus 3 minus all of x minus 4 equals 28. Let's distribute the x and distribute the negative 1. X squared plus 3x minus x plus 4 equals 28. So this is a second degree equation. Let's get it into standard form. Combine like terms here and subtract 28 from both sides. The factors of negative 24 that add to positive 2 are positive 6 and negative 4. So you get x equals negative 6 and x equals positive 4. So now we have to go back to our original equation. X minus 4 is in the denominator, so x can't be 4. X plus 3 is in the denominator, so x can't be negative 3. So in this case, x cannot be 4 and negative 3. So if I end up with one of those two solutions, I'm going to get rid of it. We had one of those two. Get rid of it. We cannot have 0 in the denominator. So we end up with x equals negative 6.